In this video lecture, we will talk about different hashing functions. Few suggested hashing functions we will look at. The different ideas for hashing functions are modulus hash function, which we have already used it, and next is mid-square hash function and folding hash function. So I'll explain about those hash functions. See, the first and the foremost requirement or the property of hash function is the hash function should be selected such that the values in a hash table must be uniformly distributed. Whether you are using chaining or you are using open addressing, that is linear probing or quadratic probing, whatever the method is used, the values in a hash table must be uniformly distributed. All the values should not be concentrated or collided at the same place every time. So this is the first and foremost property. So this is the important property of a hash function. So selection of hash function depends on a programmer or the designer who is designing a system. So one should already have the idea about the data that you are going to insert in this one. Based on that, you can select the size of the hash table as well as the type of hash function so that the collisions are avoided. If collisions are avoided, then the values will be uniformly distributed. And the next thing, if you are using chaining, then the hash table size can be anything. But if you are using linear probing, then the hash table size should be double the number of elements that you are going to insert. Suppose you are going to insert 10 elements, then the size of the hash table must be 20. It should be double. If you are using linear probing, that you are going to insert the elements only inside the hash table. So it means the loading factor of hash table must be less than or equal to 0.5, half filled. Yes, definitely you have to give extra space for achieving hashing. Now let us talk about these hash function. So first hash function, we have already seen that we have been writing this hash function h of x equals x mod whatever the size of the hash table is. So this mod function will give the values starting from 0 onwards. Suppose you don't want the values starting from 0 onwards, then you can add +1. Sometime it is taken like this also. If suppose the array is starting from index 1 onwards, then we don't want 0, we want minimum value as 1. So after that you can add 1, so that minimum value you get as 1. So anyway, with +1 or without +1, you can define a modulus hash function. Now next important thing, what should be the size of the hash table? As I said that it should be double the number of the keys, but it is preferred that the size is a prime number so that the collisions are reduced, because prime number division, because the prime numbers will have only two factors, that is 1 and the number itself. That's the reason it is suggested the size of the hash table must be a prime number. Like here, just for an example, I have taken a hash table of size 9, but it's better if it is 11, that is prime number, or 13 or 17. So it's better we take a prime number as the size of a hash table. Then we don't have to discuss much about this one. Then the second method let us look at, that is mid-square method. So that method suggests that whatever the key is, you do square of that key and take the middle digit. For example, I take a small key, let us say it is 11, key is 11. I want to insert 11. So where it should be inserted? First of all, perform square of this 11. This gives 121. Then take middle digit 2. So this 11 should be stored at index 2. While storing we follow this, and while searching also, when the number is 11, then square it, so we get 121, then take the middle digit and go to that place. Yes, 11 is found. So I have taken a small number, that is 11. If suppose key is 13, then perform 13 square, that is 169. Then the middle digit is 6, it should go on index 6. So in my example, I have taken 2 digits number, so square of that I am getting 3 digits. Suppose the key is bigger than this one, then you may get more number of digits. Suppose you have 5 digits, then you can take this middle digit. Or if you have 6 digits, after performing square, if you are getting 6 digits, then we can take middle 2 digits also. Suppose this middle 2 digits are not there in the hash table, then you can perform mod on that one. So mod is always there. So even after taking middle of a square of a key, you can still perform mod so that you can get a position within the size of a hash table. So this is the idea of mid square, taking a square of a key, then taking middle digits. You can take one digit or you can take more number of digits, that's up to you. Then let us look at folding method. Suppose a key is 123347. I have a 6-digit key. We can partition the key into more than one partitions by taking some number of digits. So here I will take two digits. Then first two digits is a number 12. The next two digit is number 33. The next two digits is 47. Then add these digits 12, 9. So we got a number 92. This 92 should be an index in hash table. So folding is we are taking digits and it is just like we are folding these digits and making them as a single number. Then this number can be used as an index for hash table, and again if you think that this number is larger, then you can perform mod, or else you can add these two digits also, like 9 plus 2 is 11. You can still add those two digits also, but while searching also you should perform the same procedure. If the index is valid, you can store the element there. Otherwise, you can again add those digits and you can fold those digits and you can generate a new number that is mapping inside the hash table or within the range of size of the hash table. So this is about numeric keys. Now if suppose a key is a string, I have a string as a key, ABC. Suppose this is a key ABC. It can be a name of a person, name of a product, or anything it can be. So I am just taking alphabets ABC. Now how this can be converted into a index in a hash table? So for this we can take ASCII codes of these alphabets like A, B, C, 65, 66, 67. This is forming three different numbers, so you can make it as a single number. Now this is like a single number, and this we can perform folding by taking 65 plus 66 plus 67. We can add all these. 8 carry 1, 198. Now this is forming three digits. Suppose this is going out of range, again perform mod, or else you can skip this carry if you want just two digits. That's up to you. So this is how a string can be converted into an index with the help of their ASCII codes. Now finally, conclusion is you can design your own hash function. Whatever the hash function you like, you can design it. Make sure that always it gives the same result. Means whenever you are passing a key 123347, then always you should get 11. Suppose if you are getting 11, you should always get 11. It's not that one time it has given some number, some other time it is giving some other number. That is not a suitable hash function. So hash function should always give you the same index. Now while storing, it has given the index, we will store it. While retrieving, again it gives the index, we go there and find it. That's all. So designing hash function is up to a designer or a programmer. So he can choose anything he wants. Even a programmer can have his own idea and he can introduce his own hash function. These are just the ideas. So depending on the data, you can think over it and you should design some hash function which avoids collision. Then one more thing, that languages like Java and .NET, these languages provides built-in hashing. Like in Java, whenever you create an object, a hash code is given for that object. That hash code is automatically generated by JVM on a system. So it may be using data and time and the location and various other values as a parameter and generating some hash code, so that that code will uniquely identify a object created. So universally it will be unique and it will be uniquely identified. So hash codes are more important in Java. You can identify any object with its hash code. So those hash codes are generated by using some parameters. So even we can design our own system where we can generate the hash code for every value that we want to store in hash table, and we can have our own hash function which is uniformly distributing the values. But in these examples we have been using the key that is a part of data. It is not a generated key. The key is a part of a data. Suppose this is a key or this is a key, or else we can have our own keys for the objects. So that's all about hashing technique. So we have discussed various topics under hashing technique. So you practice these programs, this will develop your programming skills and analytical skills.